You can always adjust the distance.
Yeah, I've been doing that.
So 33 and 37, sketching the graph. 33 and 37. Okay, let me do a hard one. Number 37. CX is 134. We want to sketch the graph of this function. So increasing, decreasing, concavity, and so on. So this one is slightly annoying because it has this square root, the third root. And with polynomials, those are easier. Okay? So I think a lot of difficulty could come from the algebra. The routines are pretty routine. The steps are pretty routine. You take the first derivative and find out where it's 0 and so on, where it does not exist, and determine increase and decrease, then you do second derivative. So with the first derivative, you apply the product rule. Okay, f prime x, that is 1/3, x to the negative 2/3, times gx, which is x plus 4, plus fx, which is x to the 1/3, times g prime, which is 1. So now what do we do from here? Well, just like polynomials, you would like to factorize out and then try to find out where it's 0. Here we're really dealing with a fractional function, a rational function, some kind of rational function because of the negative power. Okay? So just like polynomials, you can take out a common factor. Well, you kind of see that x to the some power, x to the some power. Okay, so tell me what is the common factor in this case? It's a little bit confusing because those are not the integers, positive integers. What's that? X to the 1/3. Is that what we all agree? Well, let me tell you what. You can try that. If you take out x to the 1/3, you're going to still have negative powers here. What I really suggest you to do is to take out this power. Why? Because just like polynomials, the common factors are the ones with the lowest degree, not the highest degree, the lowest degree. So here, the degree here is minus 2/3. The degree here is positive 1/3. Therefore, the lowest degree term is this one. Okay? You'll see it works better that way.
Yeah. What I did was I took out x to the 1/3, and then you have an x to the -1, which is
Negative 1.
over x.
Then you still have to work inside. Yeah. Then you put an x underneath here. It will be okay. I think eventually it will be the same as what I did. Okay. All right. So yeah. So you know what you're doing. That's good. So I'm going to take out x to the minus 2/3. Okay. I'm also going to take out the fraction because those are annoying, right? Okay. So I'm going to take out a 1/3 out. And let's see what's left. Well, we have x plus 4 from the first term, right? Okay, and then second term, what is left? You take out a 1/3, so you should have a 3 here, right? If you're not sure, multiply it out. You can see 3 and 1/3 cancel and get 1. And then what else? Well, you need an x to the degree 1, because 1 and minus 2/3 gives you 1/3. Okay. All right, let's continue. This will give us, bring the negative term to the bottom. So 3 here, x to the 2/3. Okay. And what's left here? That is equal to 4x plus 4. Are you with me? 4x plus 4, and we take out a common factor of 4 here. So we have x plus 1. All right. So now it's clear what are the critical numbers. Remember, critical numbers are the ones where f prime equals 0 or does not exist. So in this case, the critical numbers would be x equals to what? -1. That's an obvious one. Anything else? X equals 0 because that's where f prime does not exist. So we also put 0 here. And from there, you can determine where it is increasing or decreasing. What I always suggest you to do is to draw a table like this. All right? And you put the critical numbers here, from small to big. In this case, it will be -1 here and 0 here. All right? And then you put an f prime here, and then you put an fx here. So the first box here indicates the region between -∞ and -1. And here is the region between -1 and 0 and 0 to infinity. Let's put a plus minus sign. -∞ to -1. So, well, this one is going to be what? Positive or negative? I mean, 1/3 would be negative, but because of the square, it makes everybody positive. So this is really positive. Yeah? And this part is negative. Okay? Therefore, negative or positive is going to be negative. Okay? And here it will be positive. Because once x goes beyond -1, that changes the sign, so it's positive. And after 0, everybody is positive, so this remains to be positive. Yes? Let's look at the fx. Therefore, f will be decreasing and increasing and still increasing. That's the first derivative part. Let's continue and do the second derivative. Okay, f double prime. We're supposed to do f double prime. We have to. Okay, so we'll try that. Well, you can either start with this or that or that. Use any one of the expressions. Okay, so in this case, I would start with the bottom one. In fact, I would turn this into negative power, so I can use the product rule. So I'm going to start with f prime x. So before I do f double prime, let me do f prime x. 4/3 x plus 1. X minus 2/3. And now I can take each derivative. And for double prime, I'm going to combine these two together. That is my fx. And that is my gx. Okay? So f times g. So I will have f prime, which is 4/3 times g. Gx. Plus fx times g prime, which is -2/3, x to the -5/3. Right? Yes? All right, let's continue. Okay, let's take out the common factors. Let's take the 4 out, and let's also take the 3. Well, there's actually a 9 there. So let me take a 4/9 out. And then I'll take the most negative power out, the smallest negative power, which is -5/3. Yes? So I'm going to take a -5/3 out. And let's see what is left. Well, with the number, I have 4 9s. Here I have 4/3. Did I do this right? 4 9s and 4/3. I would take, I think I should take just a 4/3. 4 9s, yeah, that's right. That's good. I just need a 3 in the front, because then this to multiply gives you a 4/3. All right? Let's say x to the what power? I just need x to the 1, because that will give you this. Okay? And then here, notice there's a negative sign here. 4 9s is out, so I have the 2 left. And I still have the x plus 1 left. Okay? And that's everything. Any question? All right, let's continue. So 4 9s. Let's do this. 4 on the top, 9 on the bottom. X to the 5/3 on the bottom. Yes? And here I have 3x minus 2x, so x becomes x, and then minus 2. Any question? That is my f double prime. Therefore, I can determine where it is concave up or concave down. So notice, just like the first derivative, there are two critical numbers. I would call it a secondary critical number because they are different from the original critical numbers. So you can call it a secondary. This is just the name that I made. And I think it's useful. Those are x equals to 0 and x equals to 2. All right, and just like before, I can make another table including 0 and 2. And I have f double prime x and fx. Before 0, what happens? That is negative, and this one is negative. Yeah? So I have positive here before 0. Between 0 and 2, I will change the sign here. Therefore, it will be negative. After 2, we'll change the sign to positive. Therefore, concave up, concave down, and concave up. Are you with me? So, to sketch the graph, by the way, those are called inflection points. X equals 0 and x equals to 2. There are 2 of them. So, to sketch a graph, I'm going to sketch a better graph there. But for now, let me just try to think about this. Well, I think I really should have just sketched a better graph over there. Let me make use of the. I want to stay with the blackboard. So I have to erase this. That's okay with everyone. Moving those to just again. So to sketch the graph, I suggest that you make a table including the values of fx for those critical numbers. That would include the critical numbers here and the critical numbers there for both tables. Okay? So x equal to -1, x equals 0, and x equals to 2. And compute the fx for those values. Now I just erased the fx. Fx is x to the 1/3, x plus 4. Well, when x equals -1, gives you -1 times 3, which is -3. First point. X equals 0 gives you 0. X equals to 2 gives you 2 to the 1/3. 2 plus 4, 6. 6 times 2 to the 1/3. 6 times 2 to the 1/3, which is 2 to the 1/3 is 1 point something. So it's probably 6 point something, or maybe 7 something. Okay, so it's some number, something bigger than 6. And if you like, you can put in other values, anything you like. But maybe this is good for now. Let me try to sketch the graph here. So I suggest that you firstly plot in those points here. -1, -3. And here, 0, 0. That's 1, that's 2. 2 and 6. Well, roughly here, I should have moved my graph higher. Somewhere here, okay? So I have those points. How do we connect them? Well, you look at the graph, at the table here, you have decreasing, increasing, increasing. Remember this was -1 and 2. So roughly speaking, you have something like this, and then still increasing. This is your first step after just f prime. And then you try to do a better graph by looking at the second table. So from minus infinity to 0 is concave up. Therefore, your graph should look like this. Then after 0, between 0 and 2 is concave down. That means, up to 0, so it's still concave up. Yeah, right. 0 is the point of inflection. Then it's concave down. So you have something like this. Then after 2, it is concave up and still increasing. That means when you go like this, you get the idea. Faster? All right, let's look at the 3.7 here, 19 and 21. 7. Find the point closer to the origin. 21. Find the point further away from the origin. Let me look at 19 here. Find the point closer to the origin.
Sorry?
Can you take over?
No, I can't remember.
Previously it was 3.3. This was 3.3. 7, 19. So we have a straight line y equals 2x equals 3. We want to point the closest to the origin. Closest to the origin. Okay, so this is the optimization problem. What we need to do is to express the distance in terms of some variable and then maximize that function. It always helps to draw some kind of picture. So if you want to draw a picture, this would be the graph here. You have some kind of straight line, something like this, to the origin. I mean, your intuition tells you is where is perpendicular to the projection perpendicular to the straight line. That's where the answer should be. Okay, but we can certainly express the distance as a function of x and y. So here's the question for you: if you have a point x comma y, what is the distance from that point to the origin? Yeah, it's the Pythagorean theorem. It says the distance that we're talking about is really the square root of x minus 0 squared, which is x squared, plus y minus 0 squared, which is y squared. Any questions on this? Everybody should know the distance formula. I can write down that here if you need. Distance between 2 points, P1 and P2 on the plane is just equal to square root of x2 minus x1 squared, y2 minus y1 squared. All right. Apply that to here. Okay. So in this case, notice y is a function of x. So you simply substitute y into here. So we got x squared plus 2x plus 3 squared. Now we're supposed to find the minimum of this function. The usual procedure is take the derivative and find the critical numbers. I actually suggest you do suggest another trick. Before you take the derivative, square the distance. Then get rid of the square root. Notice that d is minimum precisely when d squared is minimum. Therefore, it's okay to square it. So I'm going to take a d squared. And I'm going to name this to be my function fx. So if you square, you get x squared plus 2x plus 3 squared, and you want to minimize that. I believe the rest you can do by yourself, can you? Should I actually do this? Basically, you compute f prime, determine where it is 0, because this one is fairly simple. There's only one critical number. And then you just have to minimize. You have to make sure it is a minimum. So you compute f prime, and I'm going to leave this to you. Remember, the solution has already been provided on practice. Hopefully that's okay. So this is the end of chapter 3. Shall we just take a pause on the video and then do chapter 4?
Okay.
Sorry, could you do? You push that button on the upper right.
You know what
On the,
In here. This one.
on the back side. Oh, you can do that as well. Yes. There is a movie button that's on the back.
Oh, this one?
Yeah.
Yeah, that's the button.